Hello YouTube viewers, welcome to our project of USB data logger. So this is my first open source project that I want to head. And what the heck we are making? Well, we are making a USB open source data gatherer. What does that mean? That simply means basically the core principle is this puppy. So we're gonna take sensor, whichever sensor is required by your project. Like for example, you can have voltage sensor, current sensor, whichever. Does not have to be this one register based one. It can be a hall effect one, whatever have you. Humidity, if you are working with something that requires that, lumen sensor, RGB sensor, temperature sensor, gyroscope, etc. Basically whatever sensor that is available. And what you're going to do is send its data to microcontroller. How you're going to send the data depends on the design. Some designs have I2C, some designs have SPI, some designs have analog pin output. That's completely up to you. Then in microcontroller, we're gonna do our special sketch, quote unquote, and this sketch will collect the data, do refresh rate, basically do it continuously and format it in CSV file. And then this puppy is gonna send the data to the software being either in Windows, either in Mac, either in Arduino, either in Linux, whatever have you. The data is gonna come here either by USB or by Bluetooth. And then what is the final result? What do you get after doing all the hassle? Well, you're gonna get a CSV file. Why exactly a CSV file? Well, it is one of the most simplest file that fulfills all the requirement without having any hassle of that. It will not work with this. It will work with Google Sheets, it will work with Microsoft Excel, it will work with LibreOffice, it will work with all quality application. If it does not work, chances are it's the application's fault, not the CSV file. So it's almost like an open source kind of file format that we can utilize. So question becomes, why do we want to do something like that? Well, reality is all professional tools already have that. That's why we do not actually think about it. Professionals will always have. And whenever you are basically doing any sort of research, any sort of data sheet of any product, especially related to electronics, be it temperature, be it whatever have you, energy consumption, amps, volts, all that jazz, they have two domain. One domain is fast domain. That is generally we require oscilloscope to see it. Well, that's fine and good and dandy. It's just that oscilloscope is like a high speed camera. You're not going to use high speed camera as a time lapse camera. For that reason, we have to utilize something very different, which we call data logger. I've already made a shorts about it. So for example, let's say this image here, you can see the current and voltage of a solar panel, and basically a big unit. How does it get affected by temperature? At 100 degrees C, it's completely different. At 75 degrees C, it's completely different. But this is over time. You cannot just like, okay, how does it happen? Do you instantly heat it up? That will have a completely different and most likely will destroy it. So you have to plot this data over time, and then you're going to get all this system where you have temperature, voltage, and current. And this is from solar panel. Then you can even have something bit different. For example, hold on. Like how does battery behave based on temperature? For example, in basically this puppy you can see in this puppy you can see like at 45 degrees Celsius the capacity of the battery is completely different compared to a minus 20 degrees C. How do you know that? You need data logging instruments to get this done. You will put a load, you will put them in a control chamber, but you have to data log it. You cannot use oscilloscopes to make something like this. You can, but good luck finding an oscilloscope that records the data for that long. So and it has to downsample at that point, so it's not right tool for it. You need to use a data logger. Professional data logger is a common thing. We do not even have to worry about it. So everything requires it. Like for example, how lumens affect the solar output. You can see that like module current based on the radiation of the sun, and things of this nature is surprisingly common in everything. Even with LEDs, you can see like each LED has a different kind of forward voltage and all that, and that's why you need constant current drivers. But again, if you can show people like why do we need constant, because on day basically minute one it does not make a sense, but over time it heats up. And I had learned this, the quote unquote the hard way, where it's like, oh, that's why we have to do this. So for this reason, it's one of those things that it's a must have. Basically, it's not optional anymore. It's a must have. If you want to do any sort of professional project, it's a must have. And all pro level ecosystem already have that. Like for there are things for like this is one of those puppies for temperature, where it data logs temperature over a long period of time. Long period depending on your requirement. It could be very long or very quick. This is an even bigger brother of that. As you can see, it has way too many channels. So there are already toolkits that allow this sort of things to be done. Only issue is they are too expensive and they are very simple in nature. Like this is a industrial level, pro level one. I'm reasonably sure you guys understand that we do not talk about the price when we are talking about something like this. So my aim is that you and I, we're gonna build something like this. Again, depending on your requirement. Like in my case, I'm just starting out with this. So I have a microcontroller and I have a voltage and current sensor here. And utilizing this, I can now properly, given some constraints, I can properly measure basically let's say 4S battery bank, lithium ion battery bank, and I can even visualize the voltage dip. Basically, let's say I have electrical load, that load is 2 amp or 4 amps. I can see, hey, at 2 amp what kind of voltage sag happens, at 4 amp what kind of voltage sag happens. All that data is priceless. That's the biggest difference between an amateur project and a professional one. Professional one already has this sort of graph. That's what you see when you see a data sheet and all that jazz. So we need this. Like, this is not optional, we need this. Now the reason why I'm doing open source, because A, I'm not that smart, and B, it's not that hard to do. It can be done, it has been done, we just need to put our collective minds to it. So I have started a GitHub project to get this done, and it has been working adequately, and people have started to help out. So right now, if you want to do this, assuming you can sort this part, basically the wiring and sketch part of it, and you can get data CSV out of it, you can use putty. Sorry, I'm looking at the side screen because I have basically putty is screenshots in this folder. So let's assume you want right now, you already have something like this. All you have to do is sketch it in such a way that it sends out the data over a CSV format, which is not that, it's just comma separated value. So you can use putty will read the serial data, and like you have to select the COM port, you have to select the baud rate, and it's going to keep reading the data. And how do you going to save it? Well, saving it, this puppy has this format option where you can save it without too much hassle. As you can see, I already did a year, month, date, and then time, and then test. That's how, and because it's actually supposed, if you write .csv, the file becomes .csv. So it was a very easy use. So you can use putty, which is fully open source and fully ready to go right now. And if you're like, hey, I want to make the software far more refined, far more fine-tuned for our use, well, you can just take this open source and strip it and add things that we need. The biggest thing missing in this, why I do not call just use putty, is, and why we need some development is needed for the sketch part of this, and the software part is simply because the putty does not allow you to tag every pulse that you are receiving. Basically, if this is sending once a second, it's not basically putty is not going to save that file where you're gonna have like, okay, this is second one, this is second two, what is the actual time to it. Now I'm very serious about that time logging part. Without time logging, especially in long-term data gathering, especially let's say you built a LED fixture that is for outdoor environment, you want to study it for 1 week, yeah, date and time, you're gonna need much higher resolution to get things going. For that reason, in putty, the best you can do is have something like this, where you have basically elapsed time. Basically, microcontroller turns on, the elapsed time is there, and then you can keep marking it down. This is just a basically analog potentiometer. I was testing it out. It does work. The project is available in the GitHub side, and you can copy paste everything, and then you can just use it as a jumping off point, and then you can go YOLO after it. So allow me to show you the bit more pro level of it. Come on, pro level of it. Yes, the pro level, the why we are building the application is this. Now you can see it not only has date as a separate system, it also has time. And this is per pulse. Basically, every pulse that is coming here is getting stored. And it does have basically milliseconds. So, and in terms of refresh rate, what sort of refresh rate that I'm targeting? My refresh rate target is basically 1 hertz for long-term project. Basically, if you are measuring something over days, 1 hertz, 10 hertz, and 100 hertz. These are the 3 options that I want to give. Now, could we add more? Well, again, if you add more hertz, then you will be more tempted to go towards oscilloscope side, and slowing it down. Well, again, that file sizes are not that big. CSV file is not that huge. So this basically this is made by me utilizing ChatGPT, and the codes are available, and GUI is not fully finished. I'm still working on it. So this is the GUI, very rudimentary GUI, as you can see, but it does work. It does work, and it does add the time tag to each pulse sent. And in terms of file naming, I'm very serious about file naming. And if you build an amazing application, it does not have good file naming, I'm not gonna append it to the main line. I'm very serious about basically naming convention. So to give you an example, that took like some development time. So I have this sort of naming convention. allow me to this. Like it took some time because apparently space bar was kind of tricky to get. So this is the final naming convention. So you're gonna have year, then you're gonna have basically month, and then you're gonna have date, then you're gonna have a space bar. That's also very important. That after that you're gonna have 24-hour clock, and then you're gonna have millisecond. Now millisecond may be a bit much. We can I'm thinking of adding a toggle, so for people who need millisecond function, they can have it. If they don't need it, which I'm reasonably sure most people don't, they can have it. And then you have a space bar. Again, it's critical. And then you have test file name, whatever name you want to put it. So even if you forget it, which happens, ask any technician who is doing this sort of thing. First time would be like, proper naming. And second time it was like WIP1, WIP2, the final two. That's why, to make sure that sort of hassle does not happen, I'm working so hard to get this exact naming convention done. And it is done so far. The code that is available on GitHub, it gives you this exact output. Spacebar is that if you press Control Shift and move arrow keys, it will only move to that space blank unit. So if for example, let's say you want to strip down the time code, you can just Control Shift, it will stop there. If I put underscore there, it will keep moving forward. So for that reason, and it's a human legible system, and the arrangement has to be this way. So it is perfectly precisely cataloged without any issue. You do not have to worry about date created, date copied, date modified, whatever else have you. You can strip the whole metadata, you can upload it to basically your Google Drive, and it will still retain all the organization that it needs to. That's why I'm so serious about the naming convention. And so far people who are working in the group have already understood it, and they are making amazing results. For example, one of the his student, if I'm not mistaken, he made something like this. It's a rather amazing and elegant way of putting it. So you just, if you do nothing, if you like, hey, I'm not feeling like, you start recording it, it has already date and time. And if you type something like, let's say LED project, let's say you just have like, hey, I'm measuring LEDs, you put LED there, battery bank, you put battery bank, whatever have you, go YOLO on it. This will allow us to basically make a system that has very good data logging without too much hassle. And I want to remove as many options in the minimum viable product. Right now we are focusing on minimum viable product, not a like finished polished system. So everything is very simplified and very minimal, but good enough where it's actually useful today. So right now, assuming you already have this part sorted, meaning whatever you need in your project, the GitHub will get you going. You will have data logging today. So that part is sorted. We are just working to make it more polished. And right now I only have this sensors. I will add the temperature sensor to it and make a sketch. So end game is making software ecosystem where people can experiment, add, and have a ready to go kit for any startup companies. Any company does not have that kind of budget to get professional data loggers, because those puppies get expensive. And if tinkerers, makers, all of them, everybody needs this. Heck, even a gardener could utilize this puppy. We already have a lot of sensor ecosystem for gardening. You have the sensor, we just gonna provide you a sketch mock-up which you can, oh, this is how we have to create it. You append whatever, modify whatever you need to, voila, now you have data logging. Now you may be like, okay, this is fine and good, but this requires a PC. Well, this is minimum viable product. Can we do all this, let's say, in ESP32 with SD cards? It should be doable. Nothing in principle is difficult, but right now I'm focusing on minimum viable product. Once we have that, like this is a minimum viable product, this works, we have testing data, graphs to show people, to make sure they understand why this sort of project is important, then we're going to move to other microcontrollers which may have better options. And final aim would be a microcontroller that's just a core kit, and then you just attach whatever you need to. You attach voltage sensor, you need current sensor, you need humidity sensor, you need soil moisture sensor, whatever have you. You just attach to it, it logs the data, and you attach multiple of it. There are many projects that are similar to it, but they only have generally one thing, like, oh, temperature, one logging. It's like, no, hundreds of it, as many as you need. Like for in this scenario, I'm using I2C bus that should allow 120 system, 120 sensors. And even this INA219, you should be able to, like, if you do not want to do any tinkering, you should be able to get 4 of them. And if you are able to change the I2C address, which I will experiment with, this should allow up to 16 I2C address. So you can have 16 of these puppy without any extra IC, just on the main link. And then you can also have other temperature sensor, other sensors that will make this far more effective. That's the whole point. Not just one sensor logging over time, multiple, a data logger. So USB is the bare minimum, and I'm utilizing this Arduino Micro or a Pro Micro. You can also try, because this chip is just one chip that has basically the microcontroller part and the USB to serial data communicator. So if you want to load anything to it, you do not need a programmer. It actually does it on its own, the IC itself. So it's a much more up-to-date IC. we can utilize this. And you have to remember the quote of our Lord and Savior, Adam Savage, is that, remember, kids, the only difference between screwing around and science is writing it down. That's why we need to have data logging, because you can say, oh, this lead acid battery is 12 volt. Anybody who knows lead acid battery would be like, lol, that's not how it works. It will have a discharge curve, something like this. So, and again, this discharge curve will also change based on the current draw. That's why you need current and voltage. And over time, only then you can truly show to someone like, this is how it is, this is how it works. Professionals already know this. All pro tools already have this. We just have to build an ecosystem for everyone else also. So I hope I have made the idea of project very clear and eloquently put it as to best of my ability. And hopefully I will get your assistance to make this project a viable, awesome project for everyone, because this is not just for me, this is for everyone. This is what I'm working on right now. Hopefully I'll see you around, and you can join my Telegram group. And if you have issue with Hindi language, you can just watch the basically USB data logger topic in there. Go to general. You have to basically sign in into general, get the captcha sorted. That's in general. After that, go into USB data logger. Here you can see a lot of people who are working on it. And then you can even help me with GitHub, because again, I'm very new to GitHub. First time using GitHub. So it's going to take some time to become proficient in it, but I'm going to use that. We already have basically YouTube if you want to communicate. And let's see how it goes. But I'm very excited, and given the fact that I already have minimum viable product, not polished, but it's working, I'm very excited. So this is my first open source project that I want all of you to help me out with. Bye.